Good morning, everyone. Welcome to the second live event for Introduction to Robotics. My name is Obadiah. I'm one of your TAs on the course, and today we're here in QUT, Queensland University of Technology, to meet the robots. I'll just introduce the other people here in the frame with us. We have your other two TAs. We have Ed and James, and we have a couple of robot researchers from QUT. We've got Chris and Gavin, and over there, which we'll pan to, is Ray. So our guests here, these robot researchers, will talk a little bit about their work and introduce some of the robots that you'll see in this room around here. We're actually in I think this is a temporary place. I don't know how permanent this is going to be, but our actual offices are being renovated. So if you guys stick around with us to the next course, the robotic vision course, we might do a bit of a tour of the new offices when they're ready. So to start us off, what we thought we'd do is, us the TAs, we might talk a little bit about the research that we're doing. If you guys have any questions or any thoughts about what we're doing, the research, or anything in general, just feel free to comment either on the YouTube post or in the EdCast forums, and we'll come back after the event to address these questions and carry out the discussion. So we might start with Ed.
Great, thanks for the introduction, Obi. So I'm a PhD student at QUT, like Obi mentioned, and I'm also one of the teaching assistants for the MOOC. So as part of that role, I answer your questions on the discussion forum and check that the content works in terms of the questions we ask you and the programming exercises. So about me, I've been a researcher or a PhD student for over 2.5 years now, and that's under Associate Professor Michael Milford and Professor Peter Cork, who you know. And I focus mostly on a field called place recognition. Place recognition is the process of identifying familiar places to you. So you may imagine you're driving along a road network, or you're viewing a scene indoors somewhere, and you want to identify that you've seen it before. So maybe from a prior visual map you've made, or some other prior source of imagery. And so it is entirely vision-based. That has a number of advantages. As you're no doubt aware, cameras are really common and they're cheap. You've got one on your phone, on your laptop, and everywhere else. Unlike, for example, laser scanners and other sensors, which can be quite cost prohibitive. So we have a number of good goals that we're working towards, and we have quite a large team on this now, with a number of professors, postdocs, and PhDs. And some of the things we're working towards are cars that can navigate along roads and indoor sort of corridor robots. And I'll link you to a video of our work, which is a camera-based GPS app for a car. And if you have any further questions, we can answer those offline.
Thanks, Ed. James?
Hi, I'm James. I'm in my final year of my degree here. My thesis project is currently using version machine learning for robotic control. I'm using multimodal deep autoencoders to do this. The idea is to avoid the need for explicit programming for some of the mundane tasks performed by robots. I've recently managed to achieve some local goal-based navigation, and just writing a paper on it at the moment.
Thanks, James. So my research looks at reading text in the world and using that for robot navigation. So as a motivating example, a lot of rooms in urban environments and in university campuses have a room label on the door or close to the door, and they tell you where you are in the space. And if you have a map of the floor, say a floor plan, or just a map that you see by the lifts, for example, and you can see this room label, you have a pretty good idea of where you are in the world. And it also, there's a lot of semantic information that's encoded in that we don't really think about. Like there are some assumptions about the numbering and the order of rooms that they generally ascend as you go one direction along the corridor, for example, generally. And so that's really useful for places where you don't have a predetermined map of the environment, which a lot of robotics applications at the moment kind of depend on. So one of the robots we're working with at the moment is, if we can pan over here, this is the GaiaBot. I'll just step over. It's pretty reliable platform. We've had it, it's good old faithful. We've had it for a few years. There's a ladybug camera at the top. This is an omnidirectional camera. There's 5 around and then 1 pointing vertically upwards. And you've got an Xbox Connect and a couple of other cameras. And then there's a computer in the base, and there's 2 Mac Minis down here as well, which do a lot of our processing, and this robot runs Robot Operating System, which is ROS. So my current work at the moment, we're working towards getting a paper into ICRO, which is the International Conference on Robotics and Automation, sort of premier conference in robotics worldwide. The deadline's coming up in a week's time, so lots of all hands on deck and not yet panic stations, but we'll see how we go. And what I'm actually doing is I'm training, so just like James has been doing, a machine learning algorithm where you show it a bunch of examples of text, and then it learns for itself how to what's text and what characters, what shape is an A, what shape is a B, for example, and learns to differentiate and recognize the different characters, the alphabets and the digits. And one of the key things that I'm working on is to generate the training set. So the training set for these machine learning algorithms tend to be very large. The more training, the more complicated the task, the more training examples you need. And I'm looking to generate all those training examples synthetically, because text is generated synthetically to start with. In terms of printed labels, they come from a computer font. So I'm looking at, can I model the lighting and the shadows and all the variants involved with a real world image in a synthetic environment. So that's it from us TAs. Again, if you have any questions, please do post down below. We do love to talk about our work. And I'll just pass over now to Gavin, who will talk about his work.
So, hi, my name is Gavin. I'm a PhD student here at QUT. My research interests are in planning and natural language processing. So what I'm looking at for my research is the ability to use natural language in order to program a robot. So currently, if you want to program a robot to do any kind of task, you generally need someone who's pretty skilled in the realm of robotics to be able to do that. Eventually, however, we would like to see robots moving into the domestic environment, in areas such as aged care. And in order to do that, we'd like the people that are going to be using those robots to be able to have the power to program them. So using natural language has a lot of advantages over other methods. It's natural, it's easy, it's efficient. Most people are pretty comfortable with explaining how to do things. Some of the disadvantages with that, however, is that people, when they use natural language, tend to assume that the listener has a degree of common sense. And if there's one thing that robots are famous for, it's actually not having common sense. So some of my research is trying to look at how we can try and emulate those kind of behaviors, as well as using natural language to build up very complex behaviors. So this robot that you see in front of you, hopefully, is a Now robot. It's one of the robots that I'm using initially to do my research on. We also have another robot called the Baxter that I'm using, which Chris will introduce afterwards. But this is a great robot to use because it's very easy to use. It's also a great teaching platform. So we've used this robot in the past with high school kids. So we've had 15, 16-year-old high school students come in, and within the course of 3 days, they're almost professional roboticists. It's a pretty rewarding experience. So if you have any questions about this robot or my work as well, feel free to ask at the end, and I will gladly answer. So thank you.
Thanks, Gavin. Chris, great, whatever you want.
All right, thanks. So hi.
Yeah.
And live event, not live.
All right.
So I guess we'll restart it once you're all set up, Andrew. And I'll just,
Yep. Sorry about that.
No, that's fine, that's fine. Technical problems, we understand that.